Hello guys, welcome to another video. Today we will be solving class 9th number system exercise 1.3. Now the first question is very easy. It says write the following in decimal form and say what kind of decimal expansion each has. Now we must remember one thing in this, that we've learned earlier, that if it is a terminating decimal expansion, it must be of the form a upon 2 raised to power n into 5 raised to power m, where n and m are whole numbers. So that means n and m can be any whole number, and if the denominator is of the form this, then it will definitely give us a terminating decimal expansion, and we can see it right here. We know that we can write it as 2 square into 5 square, and 36 remains the same. So it is clear that it will be a terminating decimal. How? Let us see. I can simply jump the decimal 2 places and I get 0.36. Now this is not of the form 2 raised to power n into 5 raised to power m. So it will be, as it is a rational number, it must be recurring and non-terminating. Okay, so let us do the division. 11 outside, 1 inside, 0.10, can't do it, again 9, so I get 99 here. Then I subtract, again it won't go, so we'll have to do it by 9, and it will keep on repeating. So I know that my answer will be 0.0909 and so on, which can be written as 0.09 with a bar. Similarly, this for 1 upon 8. Now I know that 8 can be written in the form of 2 raised to power 3, and with that I can think that 5 is there with a 0, because anything raised to power 0 is 1. So it must give me a terminating decimal expansion. I can change it to a improper fraction. 4 into 8 is 32, plus 1 is 33 upon 8, which gives me, I can simply convert it to a decimal like this, and when I multiply I will get 4125 upon 1000, which is 4.125. So it is a terminating decimal expansion. Now some people simply write the 4 alone and solve 1 upon 8, which gives me 125 upon 1000, which is 0.125, and it becomes 4.125. Same thing. Moving on, next question. We have question which says that 3 upon 13. Now again 13 is not in the form of 2 raised to power n into 5 raised to power n m. So it must be non-terminating and recurring. So let us divide and see. 13 outside, 3 inside, 0. Add 2, I get 26. Then I get 4. I cannot divide, so again I put a 0. Add 3. So I get 39. 1. And a 0 I can put. Now it won't divide, so I need another one. Now the nearest to this I can take as 91, which is at 7. So when I subtract, I get 9. Now again, some people might stop here, but I would suggest not to, because as we can see, it is a rational number, so it must be recurring and non-terminating. We must keep dividing till we get a repetition. So let's see. After 7, I can try it at 6 by putting a 0 here. So 13 into 6 I can do, which is 78, and I get 12. I hope I don't run out of space here. And then I can again put a 0, and then again at 9 I can try. 13 into 9 will give me 117. I'll be left with 3. So you can see it will go all the way to the starting. So the answer to this will be 0.230769 and a bar, because it will straight away start again from 30, which was in the beginning. So this is the one which is repeating. 0.230769 is my answer. Now let us start with 2 upon 11. We don't have space. Let's try it here. 11 outside, 2 inside. Now again, it is a rational number. It is already in the form of p by q. It must be recurring and non-terminating. So I can put a 0 decimal at 1. I get 9. I can again put a 0. I get 8. And it will go back to 2. So just do this. So you can see it's repeating. Sorry, it should be 9. So you can see it's repeating. So my answer will be 0.1818 and so on. So I can write it as 0.18 bar. So the answer to this is 0.18 bar. Moving on. This one, 329 upon 400. Now there are many ways of doing it, but we know that there's a table we've learned. Whenever you have 2, you multiply it with 5. When you have 4, you multiply it with 25. When you have 8, you multiply it with 125. When you have 16, you multiply it with 625 and so on. So here I already have 4 with 2 zeros. I can either multiply it with 25, or I can do a small trick that I know that if I multiply 400 with 2.5, I get 1000. So I can do 2.5 instead of 25. And then I can multiply 329 also with 2.5, which will give me 822.5 upon 1000. So I can jump the decimal 3 places, and the answer will be 0.8225, which is terminating and non-repeating, because the denominator is of the form, because I can write it as 2 square into 100, and 100 can be further written as 2 square into 2 square into 5 square. This is the decimal, the prime factorization for 400, sorry. Okay, moving on to the next question. Now the question says that the value of 1 upon 7 is given to us as 0.142857. Now this is a very easy question. So he's asking us to find the value of 2 upon 7, 3 upon 7. We can simply write 2 upon 7 as 2 into 1 upon 7, and 3 upon 7 as 3 into 1 upon 7, 4 upon 7 as 4 into 1 upon 7, and so on. So I can multiply 2 into 0.142857, put a bar here, and the answer will come 0.285714. Similarly, I can do 3 into 0.142857. Put a bar here. The answer will be 0.428571, and similarly I can do this, so on. So this is a relatively easy question, and this will give me 0.571428. Rest of the parts you can do on your own. Moving on. Next question says express the following in the form of P by Q. Now all of these are recurring decimals, as we can see 0.6, 0.4, and then the 7 is recurring, 0.001 is recurring. So let us see how to solve these. Now in these, let's first try 0.6. We say let x be 0.6, okay, 0.6 bar, and then x can also be written as 0.666 as many times as I want. So I multiply both the sides with 10, multiply both sides with 10. Now why 10? Because after the decimal only one digit is recurring. So I simply multiply it with 10 and I get 10x is equal to 6.666 and so on, which can be written as 6.6 bar. Now we simply subtract equation 1 from equation 2. So equation 2 minus equation 1, which gives me 9x is equal to 6. Now how 6? The bar and bar will get cancelled. I'll show you here. 6.6 bar, 0.6 bar, subtraction sign, this and this will get cancelled, because as many times this is repeating, this will also be repeating. So I get x is equal to 6 by 9, which can be reduced to 2 by 3. That's it. Now similarly, we can do the next question, which says 0.4 and 7 has a bar. So we can say let x is equal to 0.47 bar. So we can write x as 0.4. Now only 7 is repeating here. Remember, only 7 is repeating here. 4 is not repeating. So I can write it in this form. Next. Okay, so now after the decimal, I have two numbers. So I must multiply it with 100. So I can write 100x is equal to, when I multiply this, I get 47.777. So I can subtract equation 1 from equation 2. I will get 100x minus x is equal to 47.777 bar minus 0.47 bar. I can write it in this form, 47.7 bar or minus 0.47 bar. This and this will get cancelled. I will be left with 47.3 is equal to 99x. So now I can either multiply both the sides with 10, or I can first write it as 47.3 upon 99 and then multiply by 10, which will give me 473 upon 990. Okay guys, so I've cleaned up the workspace. Now coming back to the question, we had 473 upon 990. Now it is clear that both of these are divisible by 11. We can reduce it and we will get 43 upon 90. So x is equal to 43 upon 90. Now coming to the next part, again over here we can see that there are 3 decimal places. So I will write let x is equal to 0.001 and a bar. I will multiply both the sides with, as there are 3 places, I'll multiply it with 1000. I will get 1000x is equal to 1.001 bar. It's quite similar to the previous question. So subtract, we'll call this as equation 1, we'll call this as equation 2. Subtracting equation 1 from 2, we get 999x is equal to, now this and this will get cancelled out. I will be left with 1 only. So x is equal to 1 upon 999. You can verify the answer by using your calculator. The next question says express 0.999 in the form of p by q. Are you surprised by your answer? With your teacher and classmates discuss why the answer makes sense. See, basically we can see this is very near to 1. If we round it off, it will be almost 1. So let us try this. I can write let x is equal to 0.9 bar. Write it as 0.9. So as there is 1 decimal place, I will multiply both sides with 10 and I will get 9.9 bar, right? Which can be again written as subtracting equation 1 from equation 2, we get 9x is equal to 9, so x is equal to 1. So that is why they say, are you surprised by your answer? Because it is very near to 1. When rounded off, it will give us 1. Now the next question. What can be the maximum number of digits in the repeating block of digits in the decimal expansion of 1 by 17? So basically it's asking you that how many decimal places will 1 upon 17 give when you divide it. So as a thumb rule, we say that if the numerator is 1, whatever is the digit in the denominator, you subtract it by 1. So if it's 17, I will do 17 minus 1, which is 16. So I should have 16 decimal places in my answer when I divide. And when you divide, which you can do on a calculator, you will get the answer, and obviously it will be a recurring and non-terminating decimal expansion. So the answer you will get is 0.88235294117647, and if you count the number of digits, they will be 16 and they will keep on repeating. This can be checked on a scientific calculator. Okay, moving on to the next question. Now it says, look at several examples of rational numbers in the form p by q where q is not equal to 0 and where p and q are integers with no common factors other than 1, basically coprime, and have a terminating decimal expansion. So can you guess the property q must satisfy? So this we have already discussed in the previous questions. No matter which rational number you look at, if it's 3 upon 5, 9 upon 100, 7 upon 25, 19 upon 2, the denominator for all of them, which is also called the Q, will always be in the form of 5 raised to power m into 2 raised to power n, where m and n are whole numbers always. So over here you only have 5 because 5 into 2 raised to power 0 will always give me 5. So 5 is not present. 100 can be written as 2 square into 25, which is 2 square into 5 square. So it gives me the same form. 25 can also be written as 5 square into 2 raised to power 0, which is again the same form. So no matter whichever example you look at, if it has a terminating decimal expansion, it must satisfy this rule, that it must be of the form 5 raised to power m into 2 raised to power n. Write three numbers whose decimal expansions are non-terminating and non-recurring. Now we are well aware that only irrational numbers are capable of giving me non-terminating and non-recurring decimal expansions. So to give three examples, we can give the example of root 2, we can give the example of pi, we can give the example of root 3, right? Moving on to the next question. Find three different irrational numbers between 5 upon 7 and 9 upon 11. Now in order to solve this, it's easy if I convert these numbers to decimals. So 5 upon 7, when I divide, it will give me 0.714285. Now you don't actually need to do the whole division. Even if you do it till 0.71, it should be sufficient. Coming to 9 upon 11, when I divide, I will get 0.81 bar. So I know there are many decimal expansions between 5 upon 7 and 9 upon 11. But he says I want three irrational numbers. So they can be any. If it's starting from 0.71, I can put as many zeros as I want, and the same here. So the first one can be 0.7, 2, 3, 4, 5, 6, 7, anything I can write. And similarly, but it should not be repeated. Then I can put a dot. Then I can write 0.7122445566 and so on. Then I can write 0.7156677889 and so on. You can write any numbers, but the numbers should not form a repeating pattern. The pattern should not repeat. Next. Okay, classify the numbers as, now these is very easy. This is irrational because it is not a perfect square. 125, if we remember last year we have learned perfect squares, and 225 is the perfect square for 15. Next, now this is a decimal and it is a terminating decimal, so it must be rational. And sorry, this is also rational because it's a whole number. All whole numbers are rational. Next, coming back, now this we can see is clearly in the form of 7.478 with a bar, so it's non-terminating and recurring, so it must be a rational number. This is not terminating, but it is also not repeating, so it is irrational. So that's it for today, and please like, share and subscribe to my channel.